This is Shakil Ahmed. In this tutorial, we will discuss about adaptive boosting algorithm. That is also known as AdaBoost. It is a powerful enabling learning algorithm that combines many weak learners to create a single strong learner. A weak learner is basically a classifier that performs slightly better than a random guess. So the core idea behind AdaBoost is to sequentially train a series of weak learners where each subsequent learner focus on the mistake made by the previous one, just like the gradient boosting algorithm. Just the difference is that here focusing or rectifying the instead of rectifying the error rate or the loss function, we focus on updating the weight, and we try to weight those observations a higher weight which are giving a higher error or not a good prediction. So in this way, it, when we give higher weight to the observations which are creating problem, then we will get more uh, information about that observation. But in case of outliers, this method will not suggest it as a good classifier. So we'll just in this lecture we will discuss about how to perform the AdaBoost algorithm in Google using Google Colab using Python. So we start with the Framingham heart disease dataset, and we are interested in predicting 10-year chronic heart disease based on different demographic and clinical characteristics of the patient. We first import the data. I think we need to upload the data first. And if you Framingham CSV, this is available in Google. Here is the link. You can just search with this phrase Framingham this word, and you will get the data. So I have just uploaded the data, and then we will do the pre-processing. We will just check for total missing values, and then we drop the missing values in the response variable. If there is any missing response variable, we will drop them. And then for predictors, we can do, if there are a small number of missing values, then we can, what we can do, we just replace the continuous values with the mean, and if the values are categorical, we replace them with mode. But it can be done for very small number of missing values. If there are a lot a higher number of missing values, for example greater than 5%, even 3%, then we will need to do different imputation methods for imputing the missing values. So we will do the data pre-processing. We can see different number of missing values in different variables. So we will, and we have already dropped NAS in the 10-year chronic CHD, that chronic heart disease, that is our response variable. And then we will create the quantitative columns, quantitative variables, and separate data frames for qualitative and quantitative variables. And then we apply the method for replacing mean for the quantitative variables, and replacing mode for the qualitative variables. So for column in quantitative columns, now we are selecting certain columns in our data frame, and then we are checking is there any missing values, then replace them with fill NA with df column mean. Means we are finding the column of the mean after excluding the missing values and replacing them with the missing values in our data set. And then again we will check for the missing values in columns and then replace them with mode by from the cases where no missing. We just find the mode of the cases with no missing and then replace that mode in the uh, missing cases. For example, if we have missing data on marital status and then merit category is most repeated, then we just replace a few missing values with um, merit class. And then we now check the missing values. I think we need to run this first and then we can do this first. Now there is no missing value in any of the variables we have selected in this analysis. And now we will create a data frame for X excluding the 10-year chronic heart disease, that is DF drop. Then this variable is, we are dropping this variable, and then we creating another vector consisting of only the response variable, that is Y, and then we will split the data into train and test sets. For that we need to import train test split from SQL and model selection, and then X train X test we are making four different data sets by using the train test split command. And this is our data frame for X and this is vector for Y, and we are taking 20% as uh, test and rest of the 80% as training part, and then random start as 4 2. Now we can print the dimension of all the four data sets. We can see, for example, X trend has 3392 observations with 15 columns, and in test we have had 48 observations with 15 columns. And then now we are going to import the AdaBoost classifier and initiate it and fit the model to train test. So we will just import the AdaBoost classifier, and then we create a model AdaBoost classifier. The number of parameters, this is number of trees. Basically we are using learning rate is, we are keeping it as 1. You can take different values of learning rate. A smaller value will slow the learning process, but it will give higher accuracy. And even you can tune this parameter for a best for a better learning rate and better prediction. And then in this model, this is our object, model object, and then we use this object dot fit, and then give the inputs X train and Y train, and we can, the model is now trained. Now we can evaluate the performance of the model. For that we need a performance matrix like accuracy score, precision score, recall score, F1 score, and confusion matrix. And for visualization we need Seaborn and matplot library pyplot. And then we will predict from this object AdaBoost model object. We just dot predict, and then we will give the uh, input vector for the input matrix, or you can say input data frame for axis predictors. So we will get the predicted values of Y for the test set, and then we just use the Y test and Y predicted. These are the original values of Y observed values, and these are the predicted values. We use these two values to find accuracy, precision, recall, and F1 score. And then we can get the confusion matrix as well. So we can run this. We get the accuracy of 85.6%. That is a good accuracy, and precision is also good. So among all the methods we used in previous sessions, the adaptive boost classifier is giving better prediction uh, in terms of accuracy and precision, but F1 score is not that much improved. And recall is also small. Basically, uh, we just use precision and recall to obtain the F1 score. So F1 score based on these two and giving a smaller value. And now we will visualize the confusion matrix using these SNS heat map. We have confusion matrix as the input object, and are giving annotations, and the color is blue, and these are the uh, ticks on x-axis and y-axis, and these are the labels on y-axis and x-axis, and these are the confusion matrix. So we can run. This is the confusion matrix. These are the predicted values, predicted positive and predicted negative, and actual positive and actual negative. For example, we had actual 123 positives. Among them, only three positives were predicted, and 120 are false negative, and these are true negative. This is true positive, and this is false negative. This is false positive. So this is false positive. We are predicting as positive, although these are actually negative. So the darker color shows a higher number in the out of the four cells. For example, this cell has highest number of cones, around 723. And then finally, we can find the feature importance, as in almost of many of the cases we are interested in getting the risk factors, important risk factors of chronic heart disease, and we want to see which risk factor is have more importance in predicting the chronic heart disease. So we can check this. We need to import these two, as we have already imported. We don't need to import. If you want to keep, you can keep. And then from the above object AdaBoost model, we just get the feature importance with this sign. And then importance is PD series. This is our object feature importance. We have just name is here as feature importance. You can just write FI, whatever else you want. And then index X trained columns. Basically, we are selecting columns of the X training in training set, the which predictors have used. We are just extracting those predictors. And sorted importance, and then we sort the importance in ascending order, from bottom to top. We take the smallest one, then the second smallest, and so on. And then we make the plot using X on sorted importances on x-axis, and Y sort importance index. Those are the names of the sort importance, just variable names on y-axis. And then this is the color. And then you can give the X labels, Y labels, and then the plot title. You can just see here is the variable importance matrix. Here you can see these variables have no importance, and only these variables are giving greater importance, like age, glucose, systolic blood pressure, and cigarette per day, and diastolic blood pressure, and then gender, and then total cholesterol level, and BMI. So this is what we need to show in our articles if we are interested in finding the predictor which has most influence on in predicting the chronic heart disease. So these are some summaries. You can just read it. Adaptive boost model achieving an accuracy of approximately 83%. We have already discussed. And thank you.